Awesome. Thanks, everybody. Good morning, good afternoon, or good evening. I know it's a global audience here, so wherever you're dialing in from, good to see you virtually. If you're here to learn about AI, graph databases, or most importantly, airplanes, you are absolutely in the right place. So let's dive in. This is a picture that I took when I was walking out onto the tarmac at Southeast Iowa Regional Airport here in the States for my very first flying lesson. I've been a plane nerd my whole life. I've always wanted to fly, and I've recently kind of started learning and getting into the plane and doing all the real world stuff that you need to do to learn. But as most people here probably know, one of the most important components of flying, besides keeping the plane in the air, is talking to air traffic control. That involves a lot of syntax, a lot of specific jargon, and it's very important to kind of hear and understand and be able to communicate very quickly, especially when you're flying in and around busy airports, like where I am in Chicago. We've got two of them. So I started thinking about, are there ways that I could practice sort of very specific radio communication and get some more, like practice and time under my belt before it became really important when I was in a real plane. And so around that time, OpenAI released a tool called Custom GPTs. And this basically let you customize ChatGPT with specific instructions to have it perform a specific role or take specific actions in a specific order, basically customize what at that point was a very new experience of talking to a large language model. So I took this idea that I had for, practicing talking to air traffic control and applied it to the custom GPT kind of format. You can see I wrote this post back in November of 2023, almost 2 years ago. And I built this kind of custom GPT that could simulate this back and forth pretty well. But ChatGPT was a lot more limited back then. There was no ability for it to search the internet. There was a limit on how much data you could put into it, so that it didn't have enough data to actually give me, sort of real world airport information. And so that's kind of where it fell short. The main reason I wanted to practice is because I wanted to simulate flying from particular airports and what that interaction would be like in the real world. And so at this point, it was pretty good. I would say it was like a 7 out of 10, and it was cool to use, but not super useful. So I kind of just put it on the shelf and said, well, until we can make it more realistic, it's really not something that I'm going to use frequently. So I'm happy to report that, as you may have guessed, because I'm here today, I've been able to achieve a lot more of that like realism that I'm looking for. So we're going to go into briefly how that works. So what do we need for this sort of ultimate realism that we're looking for? Like I said, large language models and ChatGPT in particular basically mastered the syntax of it, but we need to make it a little bit more realistic for it to be useful. So the number one thing that we need is accurate weather, right? Weather is very important for pilots, especially new pilots, because new pilots, for example, can't fly when it's cloudy. They can't go through the clouds. They can't fly when there's excessive wind. They can't fly if it's raining or bad weather. And so it all really starts with having accurate weather, and that influences a lot of other things, as we'll see in just a little bit. The second thing we need is for our simulated air traffic controller to be able to choose a runway in a realistic way. Airports have many different runways, especially the bigger ones. And the reason for this is because the wind changes directions. And for example, when you're taking off or landing, you want the wind to be either in front of you, which is known as a headwind, or coming at you from the side, which is known as a crosswind. So if the wind direction shifts and it's behind you, that's not an ideal condition, right? So that's when you'd want to use a different runway. Air traffic controllers know this, and they give the pilots instructions based on this information. So we want our simulated air traffic controller to be able to do that too. And finally, when you get on a plane, there's a path that you take from when you sit down in your seat and the plane taxis or drives from the gate to the end of the runway that the air traffic controller has selected. This routing is different for different airports, and at bigger airports, it can be extremely complicated. So this is a set of instructions that air traffic control will give the pilot. The pilot has to copy them all down accurately and then perform them accurately so that there are no collisions on the ground, et cetera. So an important part of our simulation is that our air traffic controller can give us these instructions accurately. And finally, because we want to be able to interact with it and have a conversation with it, we're going to wrap these sort of base functions in an AI agent layer that combines all three of them. So when thinking about the architecture for how to build this, I wanted something that had logic that was self-contained. Basically, each of these individual tools, I wanted to be able to kind of reason about all on its own and edit, kind of individually work on the functionality one piece at a time. I also wanted them to be accessible via a webhook, which basically means there's a URL that I can hit. It calls the tool, it gets the response, and returns the data. So I right now have built this platform on a tool called Retool. But in the future, if I want to make it interactive via voice, I might want to move this functionality to something like 11 Labs or some other AI tool. And so making these functions accessible via webhook makes them extremely portable. And finally, I wanted them to be easy to understand, edit, and deploy, right? So you'll see some of them that I built here in just a second, and I wanted them to be able to come across to folks that I was showing them to very easily. I wanted to be able to jump back into this project at any time, and so I needed that sort of level of simplicity as well. Let's get a little more specific. So first, accurate weather, right? We talked about why that's important. And one of the first things that if you are a pilot, you will do when you sit down in the cockpit is you will put on your headset and you will usually hear an automated weather readout that sounds a little bit like this.
Information Mike, time 125 visual weather. 1060 at 7, weather is better than 5005. Temperature 27, dew point 19er. Altimeter 300.
So you see he's hearing all those instructions. He's writing down on his iPad exactly what the automated weather reading is. This is giving him a lot of information that he'll need for his flight. Basically, it's influencing how he'll fly, what the flight plan might be, all those things. So when you first call air traffic control, they want to know that you've done the sort of homework of listening to this automated reading. So they'll ask you for a designation.
Contact, you have information Mike.
All right, we have information Mike.
Information Mike.
So he's noted there that he has what's called information Mike, which is the current kind of up-to-date version of the weather, which we'll need to tell air traffic control about when we call them for the first time, right? So we need to make sure that our simulated air traffic control agent can give us this weather in the same specific format. And so what that looks like is this workflow right here. There are two kind of main pieces to this. The first piece is these two blocks here, which call aviation.weather.gov, the API, to get the current weather at a particular airport. And the second block here makes a database query to our database of all sorts of airport information, which gives us the name of the airport, location, things like that are all important for the next step, which is using a large language model to actually generate that sort of weather readout that we just heard, right? So there are a lot of specific things here in the prompt about the format, how it should dictate certain things. But basically, this takes all of that weather data that we got in the first two steps and the airport information and turns it into an actual weather readout like we might expect that actually has up-to-date, currently accurate weather information. So we'll take a look at what this readout looks like in a second, but we can now, with this in place, get real-world weather turned into the format that we might expect to hear when we sit down in our plane. So that's a good first step of our simulation. Secondly, we need to get accurate runway information, right? So this is a pretty complex calculation involving wind direction, all that stuff. Luckily, someone on GitHub has done a lot of this work for us, and they've built a tool that allows us to basically put in an airport, it looks up the weather, and it generates a diagram like this. So in this case, this is that same Iowa airport that I was telling you about. And when I took the screenshot, it was saying that the current active runways were 18 or 12. So those would be likely ones that we would receive as our instructions to take off at. So we can internalize this code because it's open source on GitHub into our workflow as well. And this is the workflow right here that allows our AI agent to determine the correct runway, right? It takes the same weather data and airport database data that we had before. And this big code block here is where it's using that algorithm to compute the current active runway. And then finally, it just returns, what the number is of the active runway that we should use. So now our AI air traffic controller can get the weather and read it back to us in the format we would expect. And it can intelligently choose an active runway based on that current weather. And finally, this is maybe the most complex part, is like we talked about, you need to be able to taxi around the airport effectively. And for a given airport, you want our simulated air traffic controller to be able to give us correct instructions. So this is what the airport at Southeast Iowa Regional looks like. And there's a lot going on here in this diagram. We don't need to pay attention to all of it. I'm just going to highlight a few of the key things. So the first thing here is the terminal, right? This is where planes start and end. This is where passengers get on. This is a very important starting point for most everybody. That's where we're going to assume our plane in this simulated scenario starts to taxi. Another important piece of this are the 4 ends of the runways. There are 2 runways, which means there are 4 ends. These are places where you can either take off or land, and they all have individual numbers, but those are very important as well. And to get from the terminal to one of these ends, you have to use any of the taxiways. And so this is where air traffic control would give you a specific route of these taxiways to get from one place to another. And that's what we want to give our agent the capability to do. And so if you squint just a little bit, and then you squint just a little bit harder, some of you based on the conference we are at might know what I'm getting at, what kind of shape this is. And no, it's not the shape of a man dabbing. It actually is a graph database with nodes and edges. And so once we have the airport modeled like this, we can put this into Neo4j and then query it to get the ideal route from the terminal to the end of one of the runways, right? So in this case, we are taxiing from the terminal to the end of runway 12, which is like the top left of that diagram we just saw up there. And you can see Neo4j tells us we start at the terminal, and then kind of going left around the circle, we go to a taxiway, another taxiway, a third taxiway, and finally then we're at the end of our runway, ready to take off. And so now that this data has been turned into a graph database and stored in Neo4j, we can write any sort of query against it that we want to get from one place at the airport to the other extremely accurately and based on the real world data that we've converted into that graph database. So that's the third and final thing that our AI agent needs to be successful. And that means all we have left to do is put it into a sort of agent wrapper that combines all three. So let's take a look at exactly how this works. So I'm going to bounce over here into Retool Agents. I've called this agent Kennedy Steve. If you want a bit of a laugh, you should put Kennedy Steve into YouTube and see what sorts of videos come up. He's an air traffic controller with a personality. So this agent here, we've given it a ton of instructions. This is essentially what I've spent the last 10.5 minutes or so walking y'all through, where we want the pilot to be able to talk to the air traffic controller. We need it to enforce the fact that the pilot has to have listened to the weather, all the different things that it needs to know about how to manage, its fake virtual airport. We give it some information about the tools it has access to, which is what we just detailed as well. And some guidelines around, when you pronounce numbers, make sure you pronounce them, 25 and not 25. That's just things about, how radio communications work in the planes. And so all these instructions we've given to our agent, we gave it access to a model, which in this case was Claude Sonnet 4. And finally, we've given it access to all three of our tools here, our Get Airport Weather tool, our Get Taxi Path tool, and our Get Active Runway tool. So I'm going to go over here to our chat mode, and we're actually going to see if we can look at this actually working. So I'm going to steal one of my past conversations here, and we're going to pretend that we're calling in on the radio and say, okay, we are, November 851 Tango Bravo. This is our call sign. We are on the ramp or at the terminal, and we're looking to go to Chicago O'Hare. I'm looking to fly home in this scenario, I guess. And we're trying to get the ATIS information, which is that automated weather information that we talked about before. So if I let it run here, we'll see it's going to start to actually think about how to interpret my request, right? And so it's going to spend a little bit of time thinking, and it's going to realize that, we are looking for this ATIS information. And so it says, I need to provide the current weather first. The pilot has properly identified themselves, which is good. I should use the Get Airport Weather tool to get the current weather. So it does that. It calls our tool, and you can see here, it returns this readout for us, which then reads back into the chat, right? So this is the same radio call that basically you heard over the radio earlier. So this looks good. The temperature in Iowa right now looks like it's 16 degrees Celsius. That's that 16. And so we'll say, great, sounds good. So we'll say Burlington Tower. This is November 851 Tango Bravo. We'll say we're ready to taxi. And then we'll importantly note that we have information alpha, which basically says we've listened to the radio, we've listened to the weather, we know the current weather, we're ready to go. So while this is thinking, let's look at what might be happening in the background. So this is the web version of that runway tool I showed you earlier. If we put in our airport designation, we will see that with the current wind, this tool is saying we would likely be given permissions to take off on runway 18, right? So let's pop back over to our agent and see if it agrees. It looks like, it knows that we've confirmed. It tries to get the active runway, and it does. It gets runway 18. And so then with that information, it's able to take another turn of the sort of agent loop and say, okay, now I need to provide taxi instructions. And this is where it queries our graph database in Neo4j. So we start at the terminal, we're going to runway 18, and it provides this path for us right here. So the final readout from the agent is taxi to runway 18 via Charlie, Alpha, and then Alpha 1, hold short of runway 18, which means don't go onto the runway. We haven't cleared you to do that yet. So Charlie, Alpha, Alpha 1. And if we want to check our work, we can actually pull up the runway diagram. And like we just looked at, we're starting here at the terminal. It said go out onto Charlie, which is this taxiway right here. So we'd take a left turn. We would take a right turn up onto taxiway Alpha and go all the way up. Its final instruction was Alpha 1, which we turn left, and we'd be here at the end of runway 18. So it's able to take all of this data we've given it and actually give us a sort of real world, very simulated, but still accurate experience of the kind of instructions we might get if we were trying to do this sort of thing for ourselves. And so now at this point, any airport that I can load into Neo4j, I can use as a practice tool for my flying in the real world. So I hope this was helpful and informational. I'm Keenan. I help build cool stuff like this with people all the time. If you have questions, you want to learn more, you can send me an email, keenan@floorboardai.com, or find me around the internet. And thanks for coming.